It's another Mate here with teacher Jenny. Join me for another topic. This time, we're going to solve exponential equation. So let's start with the first one. So this is now, all of the problems here are involving fractional bases. So let's know how to deal with fractional bases. So again, when we're solving for exponential equation, we wish to come up with similar bases. Now, if we are to look at this example, our base here is a fraction. So that would simply mean that if your base is a fraction and on the other side you've got a base which is a whole number, so you have to choose which of the following are you going to convert. Are you going to convert one whole number base there to a fractional base, or you wanted the fractional base into a whole number base? So it's up to you, it's your choice. Now, for me, I'm going to choose on fractional base, transforming that into a whole number because that would look or that would make my equation look presentable. Okay? Now, 1/2 here, if I'm going to make it into a whole number base, I would be flipping that one. Because again, when you try to flip that, that would make it into 2 over 1, and that will be equal to 2. So since we're flipping, we are going to follow your ruling in flipping your base, in which we will be following the negative exponent rule. When it says negative exponent rule, we have this under the laws of exponent or the rules of exponent, that when you have x to the negative n, this will be automatically be equal to the flipping of your base, which is x, or the reciprocal of your base, that will be 1 over x, that will be raised to a positive exponent. Later on, this will be equal to 1 over x to the power of n because we are distributing our exponent to our numerator and on our denominator. So that would look like this. Now, if we are going to do the reverse way, let's say, for example, I'm coming from a fraction, let's say 1 over x, and I'm raising this one to might be a positive exponent, then if I wanted to have that one into a whole number, then of course I'm going to flip it. Now, since I'm flipping that again or getting the reciprocal of that, my sign of my exponent will change. So that would simply mean that 1 over x, reciprocal of that, that is x over 1 or simply x. And then my exponent, which is n, will have our negative n for that. So what I'm trying to say here is, if you try to move a number from the numerator to the denominator and denominator to the numerator, literally you will be changing all the signs of your exponents. So we will be applying that one here. So since we have 1/2, that means to say once we get the reciprocal, we simply flip the numbers. So 2 will become the numerator, 1 will become the denominator, 2 over 1 is simply equal to 2. And then we're raising that to the exponent, in which we will be changing our signs on that exponent. So we have from negative x, that will become positive x. From positive 2 or plus 2, that will be with minus 2. And that will be equal to 8. Now, next one, since we're aiming to have similar bases here in our equation, we will be converting or transforming our 8 into base of 2. So how to do that one? So we then again multiply 2 all throughout until we come up with the number 8. And then count how many 2's you are multiplying there. So we have here copied 2 to the power of x minus 2. This will be equal to 2 times 2, that's 4. This is now 2 2's multiplied, this is 4. And then we have 4 times 2, that will be equal to 8. And that's the number that we have there. So how many 2's are we multiplying? We have 1, 2, and 3. Or we can have the factorization 3. So this time I'm not going to call it as prime factorization 3 because in our bases we can have those bases as composite as well. As long as you can come up with similar base, that will be applicable. So we can make use of the factor 3, in which we can come up with the continuous factor of 2. We have 2 here and then 4, and then we have to break 4 into 2 and 2. So we have 1, 2, and 3. So this is now base 2, and then we have 3 times multiplied by itself. So here we have now our similar base. So we are going to simply get our exponent and put that into an equation. So we have x minus 2. Then we write equal, and that will be 3. Then we try to move our negative or minus 2 there to the other side. So this is now x equal to 3 plus 2. This is now 5. So this is our solution. You can try to check it out by simply plugging in back on your original equation, your x, and you will get the value, which is 8 there. So that means we are correct in here. So next we go for this kind of problem. So if you can see, this is with, or this is containing, again, a fraction on the base. So we can convert our fractional base into a whole number base. So again, we try to flip this one here. So 8 over 1, that is simply 8. And then again, our exponents there will become the opposite in sign. So we have negative 3x, that will be positive 3x. We have minus 2, that becomes, plus 2, we have minus 2 for that on the next line. Next, we have 16 to the power of negative 2x plus 2. Then we have 2 to the power of 3x minus 9. So this time, we are going to look for ways in which how to make it into similar bases. So we have 8 here on the base, 16 on the base, and 2 on the base. So as you can see, we have the smallest base here, which is 2. So that would simply mean that each of the bases there will be expressed in terms of base 2. So we have here 8, that will be expressed into base 2. We have 2 to the power of 3 to the power of 3x minus 2. Then your 16 will be expressed in terms of 2 to the power of 4, because again, 2 times 2, that's 4, times 2, that's 8, times 2, that's 16. So then, this is your 2 to the power of 4, which is 16. We still have negative 2x plus 2 here. And then we just simply copy our 2 to the power of 3x minus 9 on the other side. So since we have now 2 as your bases, we can now go for solving our exponential equation. But this time on the left side, we don't have one single base, so we have to make it into one single base before we do the equating of our exponents. We are going to simplify this one here. We have inner exponent and outer exponent. We just have to multiply this one on our outer exponent. So we have 2 to the power of 3 times 3x, that will be 9x. 3 times negative 2, that will be negative 6. Then we have here 2 to the power of, again, inner exponent and outer exponent, we multiply that one. So we have 4 times negative 2, that will be negative 8x. 4 times 2, that will be positive 8. And then we have 2 to the power of 3x minus 9 on the other side. So here on the left side, we have to come up with single base. And notice if you have here bases which do not, or which are not separated with a plus or minus, automatic, this would simply mean that this is with a division. So how to do that one? We are going to simply add up their exponents using the product rule for the rules of exponent. That if your bases are the same, we simply have to add their exponents. So we have here, copy the common base. We have 2 to the power of 9x minus 6 plus negative 8x plus 8. And then this is equal to 2 to the power of 3x minus 9. Next, we simply combine like terms here. 9x plus negative 8x, that will be x. Negative 6 plus 8, that will be plus 2. This is equal to 2 to the power of 3x minus 9. Notice we have now single bases on the left side and right side. So we are now equating our exponents. So x plus 2 on the left side, that will be equal to 3x minus 9 on the right side. So combining like terms, we transfer 3x to the other side. x minus 3x. That will be equal to negative 9. We transfer 2 to the other side, so this is now minus 2. And then we have here negative x minus 3x. That will be negative 2x. That will be equal to negative 11. And we're dividing this by negative 2, and so with this one. So our x here will be equal to 11 over 2. You can try to check that up if we are correct by simply plugging in 11 over 2 on your x's there. So let's go for the next example. So this time, this is a bit complicated because again, you've got here fraction and fraction on the other side as the base. So if you've got fraction and fraction, all you have to do is to build some connection here and know if your numerator or the numerators share common bases. And the denominator also shares common bases. If it's not, then we have to do something about it. So we have here 3 as the base. So if you try to check on the other numerator on the right side, that's 64. We do not have any means to express that one in terms of base 3. So let's try to check that up if we can express that one in terms of base 4. So if you have here 4 as the base, we can have it as 4 times 4, that's going to be 16. 16 times 4, that is equal to 64. So that means our numerator can be expressed in terms of base 4. So this is now base 4. Now on the new denominator, we've got base 4 on the left side. And if you try to check up on the denominator on the right side, we've got 27. And 27, if you try to look at that for base 4, we cannot come up with base 4. So if we try to check on base 3, if we can come up with 27, we have 3 times 3, that's 9. 9 times 3, that's gonna be 27. So we can come up with base 3. So that means to say, if your numerator is base 4 and the denominator can be expressed in terms of base 3, so looking at it, we just have to switch their places. So how to do that one? So it's up to you if you try to flip the left side or the right side. It's really up to you. They will be the same. So for me, let me just try to flip my left side. So I'm flipping the left side, so that would simply mean that 4 will be at the numerator, 3 will be at the denominator, and of course our exponent here will change its sign. So here we will be with negative x, and from plus 2 that will become minus 2. So we have here 64 over 27 to the power of 2x. Now next, we are going to express our 64 to the base of 4 because from the previous discussion, we know that that will be with a base of 4. So we have to express that one. So again, we copy 4/3 and then we have negative x minus 2. This will be equal to 4 to the power of 3 out from this one here. And then we have 27 to the base of 3. That will be with an exponent of 3. And then again, we have that raised to the power of 2x. Now notice we have inner exponent and outer exponent. So we can just come up with multiplying inner exponent and outer exponent from the numerator and denominator. So we have here 4/3 to the power of negative x minus 2. We still have to copy that. And then multiplying this one here, this will be 4 to the power of 6x over 3 to the power of 6x. Now notice that their exponents are the same, so we can just let it out as one common exponent. So we have here 4/3 to the power of negative x minus 2. That will be equal to 4/3 to the power of 6x. So if you try to look at that one, we have now similar bases, so we then equate our exponents. So we have negative x minus 2, this is equal to 6x. And then again, we try to solve for x. We go for 6x, moving that to the other side. So we have negative x minus 6x. And then we move our 2 to the other side. So this is now equal to positive 2. Negative x minus 6x, that will be negative 7x equal to 2. We're dividing this one by negative 7, and so with this one. So our x here will be equal to negative 2 over 7. So there you go. So you can try to check that out by simply plugging in on that kind of problem or the original given and checking if they have the same value on the left side and right side. Okay? So I hope you were able to learn or you were able to learn something from me today and try to check out the different videos also that is under solving the exponential equation with different cases. So you try to check that out. So again, this is your teacher Jenny saying in every problem there is always a solution, and in every math problem it always follows steps or same procedure. So all you have to do is to master the steps and procedure in solving that kind of problem. So once again, I'll see you on my next video. So please don't forget to like, share, and subscribe. Bye.